Hawaii's long-dormant Mauna Kea volcano has been quietly and regularly rumbling for decades, but there's no need for alarm. The tiny earthquakes aren't signs of the volcano's unrest, and are more likely linked to gases bubbling from a pool of slowly cooling magma deep underground, researchers report in the May 15 Science. Since at least 1999, the team reports, the ground deep beneath Mauna Kea has been shaking periodically, on timescales ranging from roughly every 7 to 12 minutes. The source of the tiny quakes, each no more than about magnitude 1.5, is about 25 kilometers deep at the very base of Earth's crust. It's one of the strangest seismic signals we've ever seen, says Aaron Weck, a volcanologist at the U.S. Geological Survey's Alaska Volcano Observatory in Anchorage. The long-lasting, highly periodic rhythm of Mauna Kea's quakes is unusual. But small, deep, slow quakes are a familiar type of seismicity associated with volcanoes, says John Vidal, a seismologist at the University of Southern California in Los Angeles, who was not involved in the study. Many volcanoes have this kind of signal, known as deep long-period earthquakes, he says, such as those in Alaska's Aleutian Arc or the Pacific Northwest Cascade Mountains. What causes these deep long-period quakes, or DLPs, remains a mystery. They have been observed at depths as shallow as 10 kilometers and as deep as 60 kilometers. Scientists have generally thought that DLPs are related somehow to the movement of magma within a volcano's complicated plumbing. Sometimes, that portends an eruption. The devastating eruption of the Philippines' Mount Pinatubo in 1991 was preceded by hundreds of pulses of DLPs during the preceding weeks, but more often, DLPs don't appear to presage an eruption at all. Scientists have suggested that in cases without eruptions, the tiny quakes may be related to stress and strain caused by hot magma pushing its way into rock fractures and then cooling and contracting. If that's true, DLPs might be the groans of rocks cracking from the strain. But Weck and colleagues suggest there's something else going on below Mauna Kea. For one thing, given Mauna Kea's long dormancy and the absence of any other signs of impending eruption such as swelling of the volcano's flanks, rising magma ahead of an eruption seemed unlikely. Instead, the team suggests, the quakes may be related to gases emitted by a pool of cooling magma deep underground. As the gases leave, a process called second boiling, they seep up into fractures in the surrounding rock, pressurizing it. As the gases accumulate, the pressure builds until the rock gives a grumbling heave and then is quiescent until the pressure builds again. The discovery of DLPs below Mauna Kea was just an accident, Weck says. In 2013, he used an algorithm to pore through reams of seismic signals coming from beneath the island's most active volcano, Kilauea, which has been more or less continuously erupting since 1983 SN, the 8th of May 18. We decided to apply this technique across the whole island, because why not? And then we started seeing these signals beneath Mauna Kea, which in itself was odd, Weck says. That's because Mauna Kea, one of the 5 volcanoes that share real estate on the Big Island of Hawaii, has been quiet for a very long time. Its last known eruption was about 4,500 years ago. Weck initially thought those signals were short-term. But in 2016, he happened to look again at Mauna Kea's seismic rumblings. They were still going on, and still strangely periodic. Eventually, his team traced the signals back to the earliest data available, from 1999, and identified more than 1 million DLPs from 1999 to 2018. After pinpointing the origin of the signals to the spot deep beneath Mauna Kea, the researchers compared that location with seismic waves that had passed through the region. Those waves tended to slow down in the region, often a sign of fluids. That suggested that some process related to the pool of magma, rather than moving faults, was the probable origin of the quakes. Like clockwork, seismic records going back to 1999 show that Mauna Kea's tiny quakes, called deep long-period earthquakes, have a regular pattern. In a sequence recorded in July 2000, top, in blue, these DLPs occurred about every 7 minutes. In June 2016, bottom, in orange, they were roughly every 11 or 12 minutes. Researchers suspect these quakes are due to the buildup and periodic release of pressure from volcanic gases. Because the signals have been so consistent for so long, Weck says, he and his colleagues suspected that moving magma wasn't the trigger. Instead, they write in the study, an attractive alternative is the exodus of gases from that pool of stalled, slowly cooling magma, repeatedly pressurizing rock fractures beneath Mauna Kea, again and again, every 7 to 12 minutes or so. When you see deep seismicity, there's a temptation to assume it's a sign of unrest, Weck says. These signals can still mean magma ascent, but the point here is that doesn't have to be your first interpretation. Vidal says he finds the results intriguing and plausible. I don't think it's proof, but it's good evidence, he says. They identify something that's clearly an ongoing process that's been happening for years at regular intervals. Other DLPs, he notes, tend to be irregular or come in clusters. It's hard to say whether second boiling might be at play at other volcanoes reverberating with DLPs. There are probably several mechanisms involved, Vidal says. Creating a one-size-fits-all assessment for volcanoes has proven tricky. Each volcano has its own personality, its own inner workings. There's a movement to quantify data from volcanoes around the world, to try to come up with overarching categories and classifications, the better to understand and anticipate eruptions, Vidal adds. But it's still a bit of a black art.